I'm just looking at the compound, the questions that have come here via the Google link that was sent to you. Chirag has a question: what material can be used in the anti-stripping compound, and how can we improve adhesion of bitumen film to the surface of the aggregate? Now, generally for anti-stripping compound, binders like lime can be quite useful. Okay. Similarly, even bonding can be improved with providing binders like lime or cement sometimes in the system. Okay. But then again, there you need to be very careful with the chemistry. Do fiber reinforced plastics have poor shear strength? Okay. See, it depends, because very often what happens is a fiber reinforced plastic will have a maximized property in one direction. That is the direction in which the fibers are there. It may not have the same extent of properties in the lateral direction. So that could be one of the reasons why shear strength may be an issue sometimes, but then you can design for it to ensure that you are able to resist the shear that is coming for the particular section. So good questions, Chirag. Now, I don't have any other question except Ankit is saying assignment is difficult. So I don't know what I can do about that, but I hope that you guys can go through the details in the lecture slides and answer those questions. I don't see any other questions. I'd like you to ask the questions now if you have any questions. Do you have any questions? Or Anupama or Ananya, anything from the forum that needs to be answered?
Yes, sir. Actually, there are a few questions in the forum. We'll post it in the chat box soon.
Yeah, please do that. Yeah, yeah. Sure. Sorry, sir. No problem. I think it's fine.
It's fine, sir?
Yeah, yeah, it's okay. I raised the chair, so it's fine.
It's okay, sir?
Yeah,
no?
It's fine. It's all right. Yeah.
Yeah.
Yeah, go ahead. Students, any questions from your side? So we are almost coming to the last few weeks of the course. So you'll have your exams next month. Anything that is not very clear with respect to the course content, you can ask that now. Okay, I see some posts in the chat box. Are there any new methods which are being looked at beyond slump and cube test in India? How is this done globally? Now, there are test methods for concrete that go way beyond the slump test and the cube compression test. Slump is just simple to do on site, and it's a quick indicator of the workability of the concrete. People are comfortable with it, so they've been using it for generations now. But yes, there are other tests that can actually tell you much better about the flow properties of concrete. These flow properties deal with what we know as rheology, or science of flow of materials. Okay, and there are a lot of sophisticated methods to determine not just the resistance to flow of concrete, but also what does it take to start the concrete to flow. Okay, in rheological terms, we call that yield stress and plastic viscosity. But again, that's not something that we are going to be talking about in this course. Nevertheless, there are tests that you can do much beyond slump test. Cube compression test, of course, again, it's used mainly for its convenience and to ensure that the concrete quality is maintained through the construction project. There can be other demands also. For instance, when you're making concrete pavements, your demand could be of flexural strength. So you obviously have to test flexural strength. In several construction projects, they not only want the strength, they also want durability of the concrete. And durability can be tested by several methods, like permeability, like conductivity, like chloride diffusivity. So these are all very specialized tests that need to be performed in some situations when you have to provide the durability design of the concrete and design it for specific environmental conditions. Okay, so you have to be very clear about what is the environmental condition that your concrete is subjected to, design the right test method for that, or use the right test method for that. You don't have to design a new one every time. There are lots of test methods available. Okay. Trimukh has a question. Does UV affect concrete more than any other factors on Earth? I came across this method of concrete rehabilitation named polyionite ceramic cementitious material concrete, where they are emphasizing a lot on UV resistance. Is it a marketing strategy, or is it UV has to be kept in mind while repairing the concrete structures? Okay, so please understand this: cementitious materials, cement-based materials, that includes also other binders that are used along with cement, like fly ash or slag, as well as your aggregate. These are not at all bothered about ultraviolet radiation. You don't have any problem with UV radiation as far as concrete is concerned. But when you start using repair materials, there are polymers that you put inside. So any polymers that you put inside concrete are susceptible to damage because of ultraviolet radiation. Okay, so sunlight, all polymers degrade after a certain life cycle in sunlight because of the ultraviolet radiation. So all polymers will have the problem of sunlight affecting their properties after a certain period of time. Concrete does not have any such problems. Okay, concrete is a material that will be stable for a long time in sunlight. Ultraviolet exposure does not have any damage to concrete. But if you have polymers inside, you need to really work through that. Akhil has a question. Is there any options where aggregates will be synthetic and not natural in the future? Very interesting question, because we are coming to a stage where we may have already maxed out all the material that we can get from quarries. And it's just not a very viable solution for us to keep on quarrying more and more to get natural aggregate. So you're right, we need to look for alternative sources. Now, synthetic aggregate means you need to put in processing energy, you need to put in a lot of other raw materials to make sure that you're able to create the aggregate. Now, how do you create synthetic aggregate? You still need to have a precursor material. Okay, one example is fly ash aggregate. So you take fly ash as a precursor, these are particles. They need to be cemented together to form the aggregate sized pieces. And then these aggregate sized pieces have to be subjected to some sort of sintering process or hardening process to ensure that these fly ash particles, which are cemented together, will become strong and hard like aggregate. So it requires a lot of energy to put together a synthetic aggregate. But what is a very viable solution for the future and a natural solution? Not natural from the fact that you get it naturally, no. I'm saying a natural because it's the only solution available in large quantities, is that we start demolishing old concrete and reusing that as aggregate in new concrete. So in other words, we want to use recycled concrete aggregates. So recycled concrete is perhaps the way to go in the future to ensure that we are able to satisfy the aggregate demand without really burdening ourselves or burdening our environment by depleting our available resources of stone and sand. Okay, Mahanya is asking, what is the reason of banning of FBEC bars in foreign countries? So FBEC is, of course, fusion bonded epoxy coated bars. Okay, so this is produced by a specialized process in which the steel surface is cleaned and then a layer of epoxy is coated on top of the steel. Now, however good your process is, right? However good this process is, in several conditions, you're not able to get a perfect coating. There may be always some gaps left in the coating. What happens is, now these gaps where steel is exposed, even though it may be very minuscule, maybe less than a millimeter or less than half a millimeter in size, these small gaps in the layer, in the coating, can lead to becoming the sites at which active corrosion can initiate. And that's more dangerous than having no film at all, because when you have no film at all, you have to really wait for a long time for active sites to develop on the steel surface. That takes some time. But here, natural difference is there. That site where the film is not covering the steel is open. You can start corroding that site as compared to the other location. So very clearly, you have a major disadvantage when you have a problem, when you have the fusion bonded epoxy coated rebars not properly manufactured. And in most cases, that's what happens. Even if they are properly manufactured, the way that they are stored on site, right? Bars are stored on site and they may get damaged. The polymer film on top of the steel may get damaged and create these small gaps. Still further, when the steel bars are inside the concrete, because the polymer film on top of the steel bars, in spite of all the additional ribs and other enhancements they give on the surface, you may still lose the bonding that you get with the concrete. So in several instances, bonding failures have happened, and that has been the reason why such bars have not been accepted in several countries. Okay. Okay. Now there's a question. Sir, please explain the degree of polymerization. Okay. So you know that polymers are formed with the individual hydrocarbon units joining together and forming long chains, right? Degree of polymerization simply refers to the number of individual units that are joined together. So for instance, when you say it's a dimer, that means there are two monomeric units that have joined together. A trimer has 3 units and so on. A polymer has multiple units. So the number of units that join together to form the polymer, that is basically your degree of polymerization. Okay. And it's important because the more the number, the greater will be the molecular weight. And the greater the molecular weight, the greater will be the properties that we talked about in the lecture, right? Your modulus of elasticity, your tensile strength, all those will be highly dependent on the molecular weight of the polymer. Chirag is a question, what are graphene composite materials? No. Okay. Graphene is something we didn't really cover in the course, but graphene is capturing the imagination of a lot of researchers across the world because it's got very unique properties. So what we're doing in graphene is we are extracting from a 3-dimensional network of carbon atoms, we're extracting a layer of carbon atoms which are connected quite nicely. So what happens is you get a very thin, nano-sized material which is extremely strong. Okay, which is extremely strong. So when you use this in composites, of course, people have tried using it in construction materials like concrete also with varied results. But when you start using this in composites, it is bound to increase the strength. Another thing that is an offshoot of graphene is your carbon nanotubes or carbon nanofibers. So these are all basically extracted from this structure of carbon, structure of graphite, for instance, right? From graphite, you can get layer-wise structures which are known as graphene. And graphene actually in construction right now, it is not a viable material except when you can justify the increase in cost of your concrete for the exceptional properties that you may actually end up getting. That has not been proven completely yet. However, graphene is an excellent material for water purification, and that's where it's being used significantly. Okay, I think I don't see any other questions. That's all.
So there are a few questions related to iron, steel, and other metals.
Okay, so that was not my part. I'll try to answer. No problem.
Oh, okay, so sure. I'll share them.
Sure. Okay, Akhil has asked a question. How is the cost comparison of ductile iron versus cast iron? Is there any concern of using ductile iron besides the benefits? Cost comparison. See, cast iron has a lot of carbon in it. Ductile iron, the carbon content is controlled, right? It does not have so much carbon in it. So generally, the cast iron will have more impurities, and as a result of that, it will be cheaper than your ductile iron. Okay. Is there any concern of using ductile iron besides the benefits? The concern obviously is your corrosion, right? Your forms of iron that are low in carbon, right? Your ferrite type phases, you do get significant bit of corrosion in such phases. So that is definitely going to be one of the concerns. Corrosion is usually the concern for iron. There's nothing else, right? Rebend test. Okay. What is there something specific you want to ask about this rebend test? I just see the name rebend test there. Anything specific about rebend test? Why 135 degree? Okay. I don't have the specific thing, but I presume you're talking about the bars which are being bent to a certain whether there is the cracking on the outer periphery because of this bending. Okay, why 135? I don't exactly know the reason, but yeah, usually what happens is most of the bends that we do in construction for reinforcing bars, the maximum bend will be 135 degrees, especially when you're doing stirrups, for instance. When you make stirrups, the bars which are straight are typically bent over 135 degrees to ensure that the stirrups end up closing, right? So you have when you bend stirrups, you bend 90 degrees and then 90, and then the final bend is 135 degrees. So the maximum bend is 135. Maybe that's why they use 135 degrees as the bend angle in the rebend test. I'm not 100% certain, but I believe that should be the answer. More questions? Anupama, I thought you said there was some more questions on the steel part.
Yes, sir. Ananya is posting one right now.
Okay. Okay. Ananya has posted this question from Akhil. For the coated and galvanized rebars, the cost was shared. How does the life cycle look like for these different rebars? I guess this is pertaining to a particular graph that Dr. Pillai may have shown. Yeah, I don't have the content with me, so I'm not very sure what the answer could be. Probably we can ask Dr. Pillai to post the answer in the forum itself.
Okay, sir. That's all from the forum also.
Oh, that's all from the forum. Okay.
Yeah.
Any questions from here, from the people here? We have how many? About 8 people, apart from the TAs. And any questions from those who are here?
No,
Please
sir.
unmute. Yeah, go ahead. Please go ahead, Dr. Rajaram. Can't hear you, sorry. Okay, there's a chat post by Chirag, which says, which FRP have good strength? Okay, the strength of the FRP will depend primarily on the strength of the individual fibers. The type of fibers, like carbon fibers, will have a higher strength as compared to glass and so on. And of course, you need to select a polymer which is properly compatible with your fiber material. So
and aramide fiber?
Aramide fibers also will be very high strength. Yes, you're right. Aramide also is going to be extremely high strength.
Okay, sir.
But I think I've probably shared one plot in the lecture.
Yes,
note.
sir. Yes, sir.
Yeah.
Yes.
Any other questions?
So why the FRP have low tensile strength and high tensile? Yes, sir.
FRP has a high tensile strength. Why did you say it's got a low tensile strength?
Same tension. I have read in this book that it has low tensile strength as compared
as compared to
sir, compared to low compressive load.
No. It's the opposite. FRP will have
Okay.
very good tensile strength. See, in compression, depending on the direction you're loading, you are actually probably going to be loading in a direction that the fibers are getting compressed. So then there'll be other local failures in the fibers. In tension, all these fibers are acting together. So tensile strength is very high. for FRP.
Okay, sir.
Okay. Does usage of different grades of concrete in 1 meter cube will change any? Not able to understand. Any change in quantity of cement? Okay. When we use different grades of concrete, will there be any change of in the quantity of cement in 1 cubic meter? Yeah, there may be. No, it depends on what you're doing the design with, what type of cement you're using. The cement content may change for different grades of concrete. Generally, the way that the design works out, generally what will happen is if you have a higher cementitious, if you have a high water to cement ratio, typically we are designing for low grade concrete. Okay, a low water cement ratio is designed for a high grade concrete. So more or less what happens is cement content also is lesser in low grade concrete and greater in high grade concrete. Nikhil has a question: if phosphorus is more in steel, any effect to the structure? Now I know that phosphorus has important characteristics with respect to the corrosion control in the steel. And I guess that's how indirectly it will affect the structure also. But I don't think it has any role to play as far as the load carrying characteristics of the steel are concerned. Okay, one question: Murali Krishna is asking, which blending material is better for concrete durability? Again, it depends on what you're using. For instance, if you're designing a pavement, the durability of a pavement typically will be resistance to abrasion, right? That would be the property you want. When you're designing concrete in a marine environment, the resistance to chloride diffusion is what you need. So the material that you select has to be suitable to help the concrete achieve the required performance characteristics. So in the case of a marine application, using something like slag or maybe fly ash also would be good. In the case of a pavement, mostly what will happen is when you reduce cement content and use mineral additives, your abrasion resistance may not be favorably affected. So you may want to use something like silica fume, for instance. So depending on the application, you will use different supplementary materials that can improve your characteristics. Fuad is asking, for soil stabilization, which material is suitable? Okay, for soil stabilization, the traditional materials for stabilization have been lime and lime fly ash combinations, and maybe cement and fly ash combinations. So people have used most of these binding materials for stabilization of soil. Sheikh is asking how copper resists the UV. Okay, that I'm not very sure, but why should there be a problem of copper in UV? Copper is a metal. Okay, maybe one thing that may help is the natural oxidation on copper that happens, and you form this patina on top of the copper, the bluish colored patina that you form. I think that saves or that reduces the damage of the copper to other natural elements, but I'm not 100% sure about it. Okay, so if there are no further questions, then we can stop the session today. I'm certain that whatever questions come to your mind, you'll also post in the forum. Our TAs are answering as best as they can. If they have any difficulties, they reach out to us anyway. So yeah, I hope that all of you are studying well, and you will do well in the final exam, I hope. Yeah. Can I close then? Any Any further questions? Okay, we do have a question. Tagavel is asking, usually cement mortar blocks are used as cover blocks. Plastic cover blocks are also used. Since plastic blocks and cement mortar blocks are dissimilar materials, how it acts? Okay, cover blocks, yeah, you're right. Cement mortar cover blocks can be used. Sometimes even plastic cover blocks are used. The cover block size is quite small as compared to the rest of the concrete. So usually we find that the cover blocks don't really affect any property of the concrete. Only sometimes what may happen is you may actually get a small thin layer of separation around the cover block if it's not compatible with the concrete material. It may happen, but not all the time. Okay, numerical questions in exam for basic construction material. I guess some basic numericals may be there, but yeah, I mean, this is not somewhere, this is not a course where problem solving is majorly used, right? Fuad has a question, what are the advanced technologies that are used in soil stabilization? Now, of course, you'll have to take a course in geotechnical engineering for that, because I don't think I have sufficient information there. Okay, another question. In your point of view, what are the best alternative materials for concrete? Now, you can find alternative materials for cement, but I don't think there's an alternative material for concrete. Concrete is a combination of a cementing material and aggregate. And perhaps for the way that it has helped our construction processes because of its ability to get molded to reach the desired strength and mechanical characteristics, I don't know if there's any alternative to concrete as such. And of course, if you're in a place, if you're doing residential construction in a place where wood is available plenty, then obviously you'll use timber for construction. You'll not really think about using concrete. Similarly, if you are living very close to a regular supply of good quality brick, then you would not really rely on concrete to do the construction. So again, these are conventional construction materials, wood, brick, concrete, and so on. I don't know if there's any other material in nature or synthetic material that can actually replace something like concrete. One question on some topic, from where possibilities of questions being more in the exam. I mean, all teachers would like you to read all the topics, right? So make sure that you have a good understanding of all the topics. Alternative concrete production materials. Not sure what that is. What are the best alternative materials for concrete? Alternative production, concrete production. Yeah, again, see, that's similar to the question that was raised before. Which mineral admixture would you use? And as I said, it depends on this, on the type of environmental effect that you're likely to see. If you're likely to see chloride-induced corrosion, you would use one material. If you're likely to see impact resistance or blast resistance for your concrete, you might use a different type of raw material. So again, your choices of the supplementary materials for concrete production would depend a lot on the end application. Are there further weeks or topics like bitumen and bitumen products? I think there's only 1 week with bitumen products or bitumen and bituminous concrete. I don't think we have more than 1 week worth of lectures there. Can hemp be used as an alternative? Yeah, people have actually tried to use hemp as an ingredient of cementitious material. Lime and hemp combinations, for instance, have been used. It's a natural alternative, and it's also very interesting from the perspective of actually reducing the carbon dioxide emission footprint from a structure. So there's a lot of work going on in Auroville in this regard. Hemp. There's also a company called Hempcrete Builder. So those of you who have a chance, please look in Google for hempcrete builder. And you can actually see the kind of work that these people have done. Very interesting. Okay, another question is, what happens when we use cement brick instead of red brick? Will it cause any effect such as advantage and disadvantage? Okay, cement brick, I presume you mean concrete brick. You can't make a brick with cement, you make a brick with concrete. So concrete brick will be generally much stronger than a red clay brick. Okay, it will be much stronger than a red clay brick. Other benefit from a concrete brick is it's going to be having a much lower water absorption. So water related issues will be reduced quite a bit for your masonry walls. One disadvantage is brick is a much better insulator. Okay, as compared to concrete, brick can insulate a lot more, and for interior environment, to ensure that the heat does not get in easily, brick may be a better material than concrete. And the other issue with brick is, of course, on site, you can shape it, you can break it whichever way you want to make sure that you're able to fill in your masonry properly. With concrete, that's not possible. Okay, suddenly when I said I'm leaving, everybody is asking questions. Okay. Tridev has a question, chlorine threshold of iron bars. Now, see, your typical steel bars, when you put it inside concrete has an alkaline environment. pH is very high, nearly 13 plus. Okay. In such an environment, the steel is passive. It does not corrode. When chloride comes into the concrete from outside and starts depositing on the steel surface, it eats up the surface layer of the steel and starts corrosion. So threshold chloride concentration simply means how much the chloride needs to build up on the steel surface to start this corrosion process. Right? Chloride coming in from the exterior has to diffuse through concrete, then reach the surface of the steel, built up to a certain level, only then it will start eating up the surface of the steel. That's called the threshold concentration. Okay, another question from Roshan. Lime is eco-friendly. Then what is the problem in using it now as it was used earlier? Good question. You should tell me. We have covered so many binding materials. You should tell me why we don't use as much lime today. Okay, please realize that cement is a natural progression of the technology of lime. Lime was simply calcium oxide, which became calcium hydroxide, which became calcium carbonate. People started then experimenting, as I've described in my lectures. They found that when you enhance lime with clay, it starts getting more interesting properties. And when you burn lime and clay together, limestone and clay together, you get very interesting limes, impure limes, which are having better properties as compared to plain lime. And that's why cement was started, right? Because cement was a natural progression of the ideal combination of limestone and clay that could be burnt together to obtain this composite or to obtain this cementing material. So technically speaking, we have just advanced the technology of lime to cement. We have not really stopped using lime. Okay, we have stopped using plain lime for construction because plain lime takes a long time to gain strength. Lime has to first hydrate, turn to calcium hydroxide. Calcium hydroxide has to absorb carbon dioxide and become calcium carbonate. So all this process takes a longer time, and it cannot happen in a wet condition. This process of lime cannot happen in a wet condition. It needs the air to be dry. Concrete, which is prepared with, cement does not really need this, does not have any problem. Cement can react with water and set and harden even in wet conditions. So you can take a block of cement paste, which has just been mixed, put it at the bottom of your bathtub, fill it up with water, but you will find that the next day, the cement paste would have hardened like a rock, even inside water. That's what is the primary difference why we don't use lime today. It's very slow to gain strength and it cannot work in moist conditions. Cement sorts that problem. But of course, there are other problems with cement, but yeah, at least this is the reason why we are not using lime as a binding material today. Good. Any more questions? Okay, looks like we are out of questions for today. So yeah, thank you. I'll stop this session now. If you have any questions, kindly keep posting on the forum, and we'll get back to you as soon as we can. Thank you all. We'll close then. Thank you.